Hello, today we will solve this question number 5. Okay, it's a bit complicated, let me tell you in advance. Question number 1, the part A is quite easy. Okay, what's it? And the angle CAB. CAB, you can see this is a triangle and it is the right angle triangle, right? This is CAB and this angle is right angle, right? Why? Because this line CB is tangent to this circle. Let me call circle C1 and this circle, let me call it C2. Okay. So this line BC is tangent to circle C1. That's why it is this angle between radius and the tangent line is perpendicular 90 degree. This length is 3 centimeter, this length is 4 centimeter, and this angle we have to find out. And of course, this length is 5 centimeter is given. Okay, so how should we start? You can see if I take the tangent of this angle, uh, yes, that means take the tangent of angle A. It is going to be sine 4 by 3. So angle A is tangent inverse 4 by 3. I need to leave it as it is because I don't want to go to the approximations. Okay, so the angle CAB, so part A is clear. Angle CAB, this is equal to uh, tangent inverse 4 by 3. And yes, if I calculate this angle, it is going to be 0.927929 radians, right? Okay, now let's do part B. Part B is the perimeter of the whole shape. So the perimeter of the whole shape means we need to measure the distance from here till here and then here. Okay, up to this point. So this is the distance we need to measure. Okay, let me remind you that the arc length S is equal to r theta, remember? Okay, so if I have a circle, if I have an arc, for example, and I need to find this distance from here to here, for example, so I need to find this angle and this radius. Okay, so radius I know that for in the case of C1 it is 3 centimeter. So I need to know this angle. Okay, so if I divide this whole perimeter in two parts, let me call it P1 and P2. P1 is the perimeter on C1 and P2 is the perimeter on C2. So now you can see that P1, it is going to be 3 times the angle. Now the angle is 2 pi minus tangent inverse 4 by 3. Does it make sense or no? Because tangent inverse 4 by 3 is this angle, right? So the rest of the angle from here to here, it is 2 pi minus tangent inverse 4 by 3. And we just need to multiply with 3 to get the P1, perimeter of the one. And in the same way, P2, it is going to be the perimeter of C2, not the perimeter, complete perimeter, but the perimeter which is part of C2. Okay, so this radius is 4, and the angle over here is 2 pi minus this angle. And how much is this angle? Let me call it, okay, this is B. So what is this angle B? You can see that tangent of B is equal to what? Sine, cosine, tangent. It is 3 by 4. So angle B is equal to tangent inverse 3 by 4. Okay, so here I will have minus tangent inverse 3 by 4. Okay, so now the full perimeter of this circle, of this shape, it is equal to P1 plus P2. So I need to add these two expressions. So it will become, sorry, this is not equal. This is, yeah, and I need to erase this part as well. Okay, so this is equal to, now what is P1? It is 6 pi, you can see I'm opening this bracket, minus 3 times tangent inverse 4 by 3. And now I have to add into this P2, so this is going to be plus 8 pi minus 4 times tangent inverse 3 by 4. So I can simplify it as 6 pi plus 4, 8 pi. It is 14 pi. So it is 14 pi and minus 3 times tangent inverse 4 by 3 minus 4 times tangent inverse 3 by 4. Okay. No, I made a mistake here, I guess. Hold on a second. Yes, I'm sorry. I made another mistake here. You see, we are talking about this complete circle. So complete circle angle is from this whole angle, right? I consider only part of it. I need to consider the whole angle. So it is not this, it is 2 times this. Similarly, this is 2 times this. I'm sorry, my apology for this confusion. So in this way, this is going to be not 3, but it is 6 here and 8 here. In the same way, this is not 3 or 4, it is 8 and 6. Okay, and when I do all this calculation, it comes out to be 33.27 centimeter. Okay, I hope it's clear. My apology for this confusion. Okay, now I will go to part C, which is the area of the whole shape. Okay, let me erase the unnecessary things here because I need to, and let me warn you that area calculation is quite complicated, or at least this is what I have realized. Uh, there might be some other way, simpler way. I could not find the simpler way. Delete, return, yes. Okay, so area calculation in this particular case, it is a bit difficult, it is a bit complicated. Okay, you see, calculating the area of a circle is very easy, right? Area of a circle, we know that this is equal to pi r square. Let me change the color so that you know that I'm talking about the question number B now. Okay, so the area of a circle is pi r square, and area of a sector, right? Or let me call it sector area is equal to half theta and r square. Okay, and you can see if I put 2 pi inside of theta, it will become pi r square. Okay, now uh, the total area, I can find the area of circle C1 plus area of circle C2 minus this area which is common, because this area is counted twice if I just add the area of C1 and C2. So I need to find this area and subtract it from the total area. Okay, and the calculation of this area is quite complicated. uh, I spent a lot of time to see how it will go, but it is quite complicated. Let me show you how I would do. Uh, you see, consider this triangle. Okay, DBC, DBC triangle, and consider this sector DBC, same sector. So from this sector, if I subtract the area of the triangle, I will get the area of this part, right? In the same way, I will find the area of the other part. So this way, I will find the area of this shape. I will subtract it from the total circle. Okay, now how can I find the area of this triangle DBC? Okay, uh, you know, I need to know the distance DC, and I need to know the distance. Let me call this point E. Uh, I need to know the distance VE, right? Okay, you can see uh, this angle, let me call it theta 2, and this angle as theta 1. Okay, so um, you can see that CE distance, this is equal to 4 times sine of theta 2, right? I hope this is clear. In the same way, CD distance, it is twice of this one. So it is 8 sine of theta 2. Okay, so this is easy. I found the base of the triangle. In the same way, BE distance. BE distance is 4 times cosine of theta 2, right? Okay, so the area of the triangle BCD, okay, BCD, the area of this triangle is half into the base. Base is 8 sine theta 2, and into the height, which is BE, that is 4 times cosine of theta 2. Okay, so this comes out to be 4 times 4, 16 sine theta 2 and cos theta 2. So I just want to reduce this calculation. So if I take 8 and 2 inside, it will become sine of 2 theta 2. I hope it's clear. I'm not confusing you. Okay. And theta 2, what was theta 2? Remember? Theta 2 was equal to tangent inverse. Theta 2 was sine, cosine, tangent. Sorry, for this one, sine, cosine, in 3 by 4. And theta 1, it was tangent inverse 4 by 3. CAB, that was 4 by 3, yes. Okay. Um, so in this way, the area of the triangle BCD is going to be 8 times sine of 2 times theta 2, which is tangent inverse 3 by 4. Okay. And what is the area of the sector? Sector BCD. Okay. For this thing, again, remember the area of the sector, we use half theta r square. Okay. So this is half. Theta is basically 2 times tangent inverse and 3 by 4. Okay. Area of the sector is half theta, and r square is 16. R is 4, so R square is 16. So I will simplify it slightly. So 2 cancel with 2. It will be 16 times tangent inverse 3 by 4. Okay. Now let's come to the circle C1. So using the same philosophy, if I calculate the, consider this triangle ACD. So area of triangle ACD, this is I want to calculate. Okay. So in order to find the area ACD, oh, so let me calculate this thing first. Hold on a second. Okay. Uh, so what I'm trying to do, okay. Now I want to find the area of this shape, which is something like this, and it is C and D, and I call the center point as E. It's not important, but I'm just giving it a reference. So what is this area? So this area is equal to the area of the sector, which is 16 tangent inverse 3 by 4, minus area of the triangle, which is 8 times sine of 2 tangent inverse 3 by 4. Okay. And now I want to calculate the area of this other the other shape. I don't know what to call this shape, this one. Okay, let me erase things again so that it becomes a bit more clear. Okay, so now I want to calculate this area, which is given by this. And remember, these areas, these two shapes are not same because one circle is big, one circle is small. So I want to calculate this area. And again, I will find the area of this triangle and then area of this sector. Okay, so uh, again, I know the distance DC, but let me find it again. You see, CE, okay? CE, I'm trying to calculate as a function of theta 1. Okay, so this is CE is 3 times sine of theta 1. Agree? And CD is double of this, so this is 6 times sine of theta 1. Okay, and AE, AE is 3 times cosine of theta 1. Okay, so now I'm ready to calculate the area of triangle ACD. Okay, this area is half into the base. Base is DE, DC, which is 6 times sine of theta 1 into height, which is 3 times cosine of theta 1. Okay, and I can simplify it a little bit. It will become together with this 9 sine of theta 1 into cosine of theta 1. So I can write it as 4.5 and sine of theta 1. So it's sine of 2 theta 1. So it is basically 4.5 and sine of theta 1. You remember it is this angle. So it is 2 times tangent inverse 4 by 3. So this is my triangle ACD. Okay, now I want to calculate the sector area. Sector. Before I calculate BCD, now I'm going to calculate ACD. So this sector, uh, again, it is R theta. So R is 3 and theta is 2 times tangent inverse 4 by 3. So it will become 6 times tangent inverse 4 by 3. Okay, so this is the sector ACD. Now I want to find the area of this shape, where this is C, D, and this point is E. So I want to find this area, and this area is equal to what? It is the area of the sector, which is 6 tangent inverse 4 by 3 minus the area of the triangle, which is 4.5 sine of 2 times tangent inverse 4 by 3. Okay, makes sense. Hope I'm not confusing you guys. Okay, now the area of this shape, which is something like this. Let me draw it again a little more nicely. Okay, it is some part of the circle here and some here, right? You can see which area I'm talking about. This point is C and this point is D. So this total area is the summation of these two areas. One is this one and the other is this one. So when I add these two expressions, you can see it is going to be a bit long thing, but let me start writing it. It is going to be 6 tangent inverse 4 by 3 minus 4.5 sine of 2 times tangent inverse 4 by 3 and plus 16 times tangent inverse 3 by 4 and minus 8 times sine of 2 times tangent inverse 3 by 4. So I have to calculate the sine of this whole thing. Similarly, I have to calculate sine of this whole thing. Okay, and finally, I need some room. How can I make some room here? Okay. Mm, Erase something to, yes. Okay, I will erase this part. Okay. Okay. Now let me do things in another color so that we can differentiate. Okay, so now the area of this shape, it is area of the circle C1, area of circle C1. Remember, I call this circle C1 and this circle C2. Okay, plus area of C2 minus the area of the shape DC. I did know the points mentioned here. So area of this DC, which is, this is a circle, this is a circle, and this is something which is common between these two circles. So I hope what I'm talking about. Area of C1 is pi r square. So this is r square is 9, so this is 9 pi. Plus area of the other circle is 16 pi. And minus the area which is common, which is this expression, this complicated expression. So when I subtract this thing, something will become positive. So this will become positive. So I will, okay, let me start from here. Okay, minus 6 times tangent inverse 4 by 3. Okay, plus 4.5 into sine of 2 times tangent inverse 4 by 3 plus 16 times tangent inverse 3 by 4 and sorry, this plus, this is not plus, this is minus. This is minus and this is plus. Excuse me. Okay, so this is minus, this is plus, this is again minus, and this is plus 8 times sine of 2 times tangent inverse 3 by 4. Okay, I hope everybody is with me. I'm not confusing anybody. Okay. I made again some mistakes here because hold on a second. This is 16. Okay. And then 8 and then 9. Okay, no, I think I'm correct. Sorry. Okay. So this is 8 plus 4.5. Okay, minus 16 and minus. Is this 6 or this is 9? I solved it before and somehow I put 9 here. Okay, this is what? This is the area of the sector. And how do you find the area of the sector? Area is half. Okay. Yes, half. And then how do you find the area? Yes, this is 16 half and then angle and then this. Okay. Yes, I made a mistake here. Okay, let me correct it. Okay, so area is half and then theta and then r square. So r square is 9 here. So 2 cancel with 2, I will get 9 here. So yes, this is not 6, it is 9. My apology again. There are so many calculations, I make mistake again and again. Okay, in the same way, this is not 6, it is 9. Okay, and that's why this is not 6, it is 9. Okay, I hope everything is correct now. This is minus 9, 10, and this is 4.5, 4 by yes, and that's minus 16, 3 by 4, and plus 8, yes. And when you calculate all of these things, the area comes out to be 71.898 centimeters square. Okay, so this was pretty complicated problem. I hope you all follow it. Thank you very much for watching. See you in the next video.